Okay, so for this experiment I have three masses suspended. This is the one mass, this is the two mass, this is the four mass. The one mass is hanging 4 times as high as the two mass and the four mass. On each mass I have glued a nail at the bottom. And here is the block of foam. So what I'm going to do is I'm going to burn the wire, and then it will fall down, it will penetrate the foam, and then we will see how much the masses penetrate the foam. Now the difficult part was to make sure that the nail is hanging perfectly in the center of this mass. So it's not hanging perfectly straight, but I try my utter best to make sure that the nail is perfectly pointing downwards, so that when it falls down to the foam, it will penetrate a perfectly straight line, or at least as best as possible, as straight as possible. So now let me show you, let me prove you that this is 4 times as high as this one. So the 0 mark is at the foam, and you can see that the bottom of this coin is at 36 centimeters. 36 centimeters. So yeah, okay, so where is the center of mass? The nail itself weighs about 2 grams. So the center of mass is a little bit below the middle of this object. So like this is the middle of the object, so the center of mass is probably around here. Now this one. So 36 centimeters, which means that divided by 4, the bottom of this mass is at 9 centimeters. Hold on. Okay. See that? It's 9 centimeters. Hold on. Focus. I hope you can see that. It's 9 centimeters. The bottom of the mass. The same with the other one. Bear with me. Alright. Okay, so let's see. There we go. Hold on. Really difficult to do this with one hand. 9 centimeters. You can see that, right? 9 centimeters. Okay. So this one is hanging 4 times higher than these two. All right, so here's the one mass, which is about 26.5 grams. So we should have around 52, 53 for the two mass. So 52 and a half. All right, and for the four mass, we should have, I guess, 104. We have 105.35. So these are the weights, the masses. So now I'm going to let them drop. Let's see. Right, that's the one mass. Now the two mass. Now the four mass. There we go. Look at that. Now I'm going to mark them. I'm going to mark the bottom. First of all, I'm going to turn the screen. Seems like the one mass didn't really land perfectly straight. A little bit at an angle. The other ones are pretty straight. All right, so now let's take this one out. Right, so this is the one mass. This is the mark. Let's see how big how long the penetration depth was, so seems to be around 3.5 centimeters. 3.5 for the one mass. Now let's take the 2 mass out, or let's first try the 4 mass. All right, so 3.5 for the 1 mass. Now the 4 mass. As you can see, it's also 3.5 centimeters. Yep, that's correct. It's the same. So now the 2 mass. Let's pick it out. So this one is only about 2 centimeters. The other one is 3.5. The 2 mass only has a penetration depth of 2 centimeters. So once again, what a coincidence that 4 mass going 1 velocity has pretty much the same penetration depth as the 1 mass going 2 velocity. What a coincidence, just as in my previous video and then the one before that. They all had pretty much the same penetration depth, or the same stretch in the rubber band. And unfortunately, the 2 mass going 1 velocity did not have the same penetration depth once again. So this time I have dropped them vertically, and then we have the same results as letting them drop sideways as in my previous video. So once again, this is proof that momentum is not the same as energy. One atom moving 1,000 miles an hour does not have the same capacity to do work as 1,000 atoms going 1 miles an hour. The truth is, 4 mass going 1 velocity has the same capacity to do work as 1 mass going twice the velocity. And here is the goddamn proof once again.